15th of March, 1943. RAF Coastal Command Station, St. Naval, Cornwall. The Liberator bomber sits on the rain-soaked tarmac, its 4 engines already warming in the pre-dawn darkness. Inside the fuselage, Flying Officer James Dudley checks his equipment one final time. The usual ordnance is absent. No bombs nestle in their racks. No depth charges hang ready for release. No torpedoes occupy the weapon stations. Instead, mounted in a streamlined housing extending from the aircraft's tail, sits something that looks rather like an oversized beer barrel wrapped in copper wire and festooned with mysterious electronics. The ground crew had been baffled when they first saw it. Some speculated it was a new type of radar. Others thought it might be some sort of radio navigation aids. None guessed the truth. Within 6 hours, this peculiar device will detect a German U-boat prowling beneath the Atlantic waves without ever making contact with the water, without sending any signal the submarine can detect, without giving the enemy any warning whatsoever that they've been found. The submarine's crew will have no idea they've been discovered until Dudley's aircraft banks sharply overhead and the depth charges begin their fatal descent. The technology responsible sits silent in the tail boom, listening to whispers of magnetism that betray the U-boat's steel hull 30 meters below the surface. Dudley adjusts his headset and studies the unfamiliar dials before him. The needles rest at 0, but he's been briefed on what to watch for. A deflection, a tremor in the magnetic field, a distortion that shouldn't exist unless something large and metallic lurks beneath the waves. The scientists who developed this equipment spoke of gamma measurements and flux densities and magnetic anomalies. Dudley thinks of it more simply. The device finds steel that doesn't want to be found. This is the story of the airborne magnetic anomaly detector, the weapon that transformed submarine hunting from educated guesswork into precise science. It represents one of the war's most significant technological leaps, a device that exploited fundamental physics to pierce the ocean's concealment. What makes it remarkable isn't just its effectiveness, but its sheer audacity. Whilst other nations focused on better ways to attack submarines once found, British scientists asked a more fundamental question. What if steel itself could never hide? What if the very material that made submarines possible also made them permanently detectable, regardless of depth, regardless of visibility, regardless of any measure the enemy might take? The strategic situation facing Britain in early 1943 was approaching catastrophic. German U-boats were sinking Allied shipping faster than it could be replaced. In the first 20 days of March alone, 97 merchant vessels would go to the bottom, carrying 627,377 tons of desperately needed supplies with them. The mathematics were brutally simple. If the rate continued, Britain would be starved into submission before American industrial might could turn the tide. Every convoy that sailed represented a calculated gamble. Every merchant sailor who signed on understood the odds were grim. Of the 185,000 men who served in the British Merchant Navy during the war, 36,749 would never return, giving the service a casualty rate higher than any of the armed forces. The wolf packs, as the Germans called their coordinated U-boat groups, had refined their tactics to devastating efficiency. They hunted in groups of 15 to 20 boats, spread across the convoy routes like a net. Once a convoy was spotted, the U-boats would shadow it, calling in reinforcements, then strike at night when visual detection was nearly impossible. Surfaced U-boats could outrun most escort vessels, and submerged boats could slip beneath convoy screens with relative impunity. Admiral Karl Dönitz, commanding the U-boat fleet, believed he needed to sink 700,000 tons of Allied shipping per month to win the war. In March 1943, he was exceeding that target. Existing methods of submarine detection had reached their limits, and everyone knew it. ASDIC, the underwater sound detection system that the Royal Navy had pinned such hopes on, was effective only when a ship passed almost directly over a submerged U-boat. Its maximum detection range was roughly 1,500 meters under ideal conditions, but those conditions rarely existed in the North Atlantic. Rough seas, temperature gradients in the water, and the noise of a ship's own engines all degraded performance. Against submarines running on the surface at night, ASDIC was completely useless, detecting nothing but the sound of waves. Radar could spot surfaced U-boats, but only at relatively close range, typically less than 8 kilometers, even with the latest centimetric equipment. German crews had become expert at diving at the first hint of an approaching aircraft, and their lookouts were trained to spot aircraft long before radar detected them. A U-boat could submerge in less than 30 seconds. By the time an aircraft reached the dive position, the submarine would be 20 meters down and accelerating deeper, leaving nothing but a swirl of disturbed water to mark where it had been. Visual searches were better than nothing, but hopelessly inadequate given the vast expanses of ocean and the limited time aircraft could patrol. A U-boat's conning tower presented a target roughly 2 meters wide, protruding perhaps 1 meter above the waterline. Spotting such an object from an aircraft flying at 150 meters altitude, scanning thousands of square kilometers of gray ocean beneath gray skies, with spray reducing visibility and waves creating countless false targets, tested human perception beyond its reasonable capacity. Pilots spoke of staring at the ocean until their eyes ached, seeing U-boats in every whitecap and missing the real ones entirely. The numbers told a grim story that couldn't be argued with. In 1942, Coastal Command flew 35,000 anti-submarine sorties. They sighted U-boats on just 218 occasions. Of those sightings, they managed to press home attacks only 74 times. They achieved confirmed kills on precisely 5 U-boats. That represented 1 U-boat destroyed for every 7,000 hours of flying time, an effectiveness rate that could charitably be described as abysmal. The Atlantic was simply too large, U-boats too small and too capable of disappearing beneath the waves. Something fundamental needed to change, not an incremental improvement, but a revolutionary approach to the basic problem of detection. The question was whether such a revolution was even possible. The solution emerged from the Admiralty mining establishment at Havant in Hampshire, though its theoretical foundations stretched back decades into pure physics. Scientists there recognized that a submarine, despite being submerged, despite being invisible to radar and hidden from visual observation, carried an unavoidable signature. Its steel hull created a disturbance in Earth's magnetic field. This wasn't theoretical speculation. It was measurable, demonstrable fact. The Type 7 U-boat displaced roughly 760 tons, most of it steel. That much ferromagnetic material inevitably distorted the magnetic field around it. The challenge was detecting that disturbance from a moving aircraft whilst filtering out interference and distinguishing genuine submarine signatures from geological variations. The device they developed was designated Type F Mark IV, though crews simply called it the detector. At its heart sat a magnetometer based on principles developed before the war for geological surveying. The core component was a detector head containing a coil suspended to rotate freely in response to magnetic fields, connected to extremely sensitive amplification equipment that could detect variations as small as 1 gamma, roughly 1/50,000th of Earth's overall magnetic field. To put that in perspective, it could detect a magnetic disturbance equivalent to a steel filing cabinet at 30 meters distance. The engineering challenges were formidable. The detector needed to distinguish between a submarine's magnetic signature and the massive field generated by the aircraft carrying it. This was like trying to hear a whisper in a foundry. The solution involved mounting the detector as far from the aircraft's engines as possible, typically in a tail-mounted boom extending roughly 3 meters behind the fuselage, then employing compensating coils that canceled out the aircraft's known magnetic signature. Third, using differential measurement techniques that looked for changes in magnetic field strength rather than absolute values. Operators learned to recognize the characteristic submarine signature, a sharp spike in magnetic field strength that rose and fell rapidly as the aircraft passed over the contact. Geological features produced broader, more gradual variations. Wreckage gave confused, irregular readings. A U-boat's signature was distinctive once you knew what to look for. The device weighed approximately 68 kilograms, compact enough to retrofit into existing patrol aircraft without significant modifications. Its effective detection range depended on multiple variables: submarine size, depth, orientation relative to Earth's magnetic field, and local geological conditions. Under optimal circumstances, a submerged Type 7 U-boat could be detected from roughly 150 meters altitude when the aircraft passed within 120 meters of the submarine's position. That represented a detection range roughly 5 times better than visual observation under typical North Atlantic conditions, and it worked regardless of weather, time of day, or sea state. Detection range decreased with depth. A submarine at 10 meters could be detected reliably. At 30 meters, detection became more difficult but remained possible. Below 50 meters, even the sensitive British equipment struggled. This limitation actually worked in the Allies' favor. U-boats hunting convoys operated at periscope depth, typically between 10 and 20 meters, precisely where the magnetic detector was most effective. Manufacturing took place at several locations. Final assembly concentrated at the Telecommunications Research Establishment's facility at Malvern, where calibration equipment and expertise were centralized. Production figures remain partially classified, but available records suggest approximately 600 units were built between late 1942 and mid-1944. Each unit required roughly 120 hours of skilled labor to assemble and calibrate. A poorly calibrated detector was worse than useless, generating false positives that sent aircraft chasing geological anomalies whilst real U-boats escaped. The calibration process took roughly 40 hours of flight time per aircraft, an enormous investment when aircraft were desperately needed for operational patrols. Operational deployment began in March 1943, initially with just 12 specially equipped Liberators operating from coastal command stations in Cornwall and Northern Ireland. The aircraft were drawn from 19 Squadron and 172 Squadron, units with experience in anti-submarine operations and crews considered capable of handling the new equipment effectively. The selection process was rigorous. Not every pilot had the patience for the methodical grid searches the detector required. Not every navigator could interpret the subtle variations in magnetic readings that distinguished genuine contacts from false alarms. The crews required extensive training, not in operating the equipment itself, which was largely automatic once switched on, but in interpreting its readings and coordinating attacks based on magnetic detection. The detector provided bearing and approximate distance to a magnetic anomaly, but exact depth remained unknown. Attack procedures required the aircraft to circle the detected position whilst deploying sonobuoys, listening devices dropped by parachute that could provide more precise location data through ASDIC contact before depth charges were released. The entire process, from initial magnetic detection to weapons release, typically took between 6 and 12 minutes, assuming the contact was genuine and the submarine hadn't moved significantly. The first confirmed kill using magnetic detection came on the 19th of March, 1943, just 4 days after the system entered operational service. Flight Lieutenant John Roxburgh, flying Liberator AM-924 from St. Aval, detected a magnetic anomaly whilst patrolling southwest of Ireland in an area designated as a U-boat transit zone. The sea was empty to visual observation. Visibility unlimited to the horizon, the sun bright enough that crews typically complained about the glare off the water. Yet his detector insisted something steel and substantial lurked below, the needles swinging sharply as the aircraft passed over the contact position. Roxburgh was experienced enough not to attack immediately. False alarms had occurred during training. Wreckage from previous battles littered these waters. He circled back, dropped a sonobuoy, and waited. The distinctive ping of ASDIC contact confirmed what the magnetic detector had indicated. Something large and metallic sat beneath the waves, roughly 30 meters down based on the sonar return. 8 depth charges followed, set to detonate at 30 meters depth, arranged in a pattern calculated to bracket a submarine attempting to evade. U-384 never surfaced. Oil and debris marked where she'd been. Her entire crew of 48 men died without ever knowing what had found them, without seeing the aircraft that ended their war. Records from the next 6 months are fragmentary, some remaining classified, others lost in the fog of war and inadequate record-keeping. Confirmed kills attributed to magnetic detection during this period include U-456 on 12th May, U-409 on July 5th, and U-613 on July 23rd. The exact circumstances of each attack remain unclear. After-action reports mention magnetic detection contacts, followed by depth charge attacks resulting in oil, debris, and no surfacing submarine. Whether the submarines attempted evasion, whether they were aware of being hunted, whether crew members survived the initial explosions only to drown as their boat sank, these details are simply unknown. What is documented is that U-boat losses in areas patrolled by magnetic detector-equipped aircraft increased notably. Whether this represented the direct effectiveness of the equipment or its indirect effects on U-boat behavior remains a subject of debate among historians. What's certain is that German submariners operating in areas known to be patrolled by coastal command aircraft began reporting a disturbing trend. Attacks with no warning, in perfect concealment conditions, by aircraft that appeared to possess some form of detection capability that penetrated the ocean's surface. The psychological impact on U-boat crews was profound. German submariners had grown accustomed to a certain rhythm of danger. They understood radar, could see aircraft approaching, knew when they'd been spotted. The magnetic detector changed everything. Boats were being attacked with no warning, in conditions of perfect concealment, by aircraft that appeared to know exactly where they were, despite the U-boat being invisible beneath the waves. Interrogations of captured crews revealed a growing sense of helplessness. The ocean, which had been their ally and protection, had apparently become transparent to some unknown British capability. German naval intelligence knew something had changed, though they never fully identified what. Reports suggested the British had developed enhanced detection equipment, but the exact nature remained mysterious. Some analysts theorized about infrared detection of submarine wakes. Others suggested acoustic systems sensitive enough to hear diesel engines through the hull. None identified the magnetic principle, largely because it seemed improbable that equipment could be made sensitive enough to detect submarines at operationally useful ranges. German countermeasures proved largely ineffective because they never fully understood what they were facing. Some boats attempted degaussing, running electrical current through their hulls to reduce magnetic signature, but this had minimal effect against the sensitivity of British detectors. Others tried deeper diving, which did increase detection difficulty, but made effective patrol operations nearly impossible. The simple truth was that a U-boat built of steel could not eliminate its magnetic signature without ceasing to be a functional submarine. If you're finding this interesting, a quick subscribe helps more than you know. It allows us to keep making these detailed histories. The Americans developed their own magnetic anomaly detector independently, designated A, N/A, Q-1, entering service in late 1943. The American version used different principles, employing a flux gate magnetometer rather than the rotating coil design favored by the British. In comparative trials conducted in early 1944, the British Type F Mark IV demonstrated slightly better sensitivity, detecting test submarines at roughly 15% greater range. However, the American design proved more robust and easier to manufacture, leading to larger-scale production of roughly 2,400 units compared to 600 British units. The Germans never successfully deployed an airborne magnetic submarine detector. They experimented with similar technology at Kiel in 1944, but efforts were hampered by lack of resources, Allied bombing, and the fundamental problem that they had far fewer submarines to protect than the Allies had to hunt. German efforts concentrated on better radar warning receivers, snorkel equipment, and revolutionary submarine designs like the Type 21. None addressed the magnetic detection problem because the Germans never fully understood it existed. The actual strategic impact of magnetic detection remains difficult to quantify with precision. Available records suggest that magnetic anomaly detectors were directly responsible for between 15 and 23 confirmed U-boat kills between March 1943 and May 1945. That number sounds modest, but misses the broader picture entirely. The detector's true value lay in force multiplication. Aircraft equipped with magnetic detection covered their patrol areas far more effectively than those relying purely on visual search. A single detector-equipped aircraft could survey an area roughly 3 times larger than a conventional patrol aircraft in the same flight time. More significantly, the magnetic detector fundamentally altered U-boat tactical doctrine. German submarines increasingly operated at greater depths to reduce detection possibility, which reduced their ability to observe and track convoys. Battery endurance meant sustained deep diving wasn't practical, forcing boats to surface more frequently to recharge, where they became vulnerable to radar and visual detection. The magnetic detector created a tactical dilemma with no good solution. Stay shallow and risk magnetic detection. Go deep and sacrifice operational effectiveness. Surface regularly to recharge and risk radar detection. The technology influenced post-war anti-submarine warfare doctrine across all major navies. Modern magnetic anomaly detectors, vastly more sensitive than their wartime predecessors and incorporating sophisticated digital signal processing, remain standard equipment on maritime patrol aircraft worldwide. The American P-8 Poseidon carries the AN/ASQ-235 system. Russian Il-38 patrol aircraft carry the APM-60 system. The basic principle that steel cannot hide from magnetism regardless of depth or concealment continues to underpin submarine detection strategies. Several museums display preserved examples of wartime magnetic detection equipment, including the Imperial War Museum, Duxford, and the Canadian Warplane Heritage Museum, though finding complete operational Type F. Mark IV units is exceedingly rare due to post-war classification and subsequent disposal. Most surviving examples are incomplete, retained as historical curiosities rather than functional devices. March 1943. The Liberator climbs into darkness, its strange cargo humming quietly in the tail. Below, the Atlantic stretches black and endless, concealing hunters that have grown too comfortable in their invisibility. But steel has memory, and magnetism has patience. What appears empty to human eyes reveals itself to physics. The ocean keeps secrets, but iron cannot lie about its presence. Before this war ends, 630 German submarines will rest on the Atlantic floor, their steel hulls creating tiny distortions in Earth's magnetic field that will persist for centuries. Some were found by radar, some by chance, some by the desperate courage of convoy escorts, and some by a copper coil spinning in a magnetic field, whispering secrets that the water could not keep. The magnetic anomaly detector didn't win the Battle of the Atlantic alone. No single weapon ever does. But it represented something fundamental about how Britain fought: the willingness to question assumptions, to apply pure science to brutal practical problems, to transform the invisible into the detectable. In the end, the U-boats lost not because they were beaten by superior force, but because the very ocean that concealed them became transparent to those who understood that every piece of steel carries within it an unavoidable announcement of its presence. You cannot hide what you are made of. Physics doesn't permit exceptions, even in wartime. The device that destroyed submarines without touching water did so by understanding a simple truth. The sea may hide what the eye cannot see, but it cannot hide what magnetism reveals. In that revelation lay the difference between convoys sunk and convoys saved, between Britain starved and Britain surviving. 68 kilograms of wire and electronics mounted in a tail boom, listening to the whispers of disturbed magnetic fields. It was enough.